Welcome to the Slop Temple. We pray this video helps.
You start by making the tool safe. Remove batteries and unplug any external leads so you can work without hazard. Once done, open the case and examine the PCB under good light. You want to find cracked solder joints, corrosion, or visibly damaged components right away. Make sure to label any connectors you remove so reassembly is painless. You'll also check the test probes and cable continuity quickly with a handheld multimeter to confirm whether the issue is in probes or the main unit. You now move into targeted diagnostics. With batteries fitted, measure voltage across the power rails to verify supply and any regulator drop. After that, use the diode and continuity functions to test LEDs, buzzer, and the continuity switch so you can isolate which stage fails when probes touch. Once you identify a suspect component, rehearse the replacement by fitting it dry to confirm compatibility. If a trace is broken, plan a jumper repair before irreversible soldering so you preserve board integrity. You complete repairs by replacing failed components, reflowing suspicious joints, and bridging any broken traces with thin jumper wire. Use flux and clean residue after. Then reassemble enough to test. Fit batteries and confirm normal audible/LED indications using a confirmed short and a few known resistor values. Make sure the probes and cable are secure. If it still misbehaves, check for intermittent faults by flexing leads and stressing connectors. That often reveals broken wires or poor strain relief. Fix those last.
Thanks for watching. Consider subscribing if we helped you.